Here's an application problem. Workers at a hardware store take their morning break no earlier than 10 and no later than noon. Let's C represent the time the workers take their break. So we're going to write an absolute value equation that represents the situation. So it's always easier to see it. So let's go ahead and draw a timeline. You could call it a number line, but I'm going to call it a timeline. So we start at 10. That's when we can take our break, and we can end at noon. Okay, so that means that we can take our break in here. That's when we want to take our break. So if we want to write an equation that helps to tell us when we could take our break, then what we're going to do is write an absolute value, which means that we have to find the center. So the center is right here. So these numbers are pretty easy to see that our center time is going to be 11. But if we didn't know that, and because they were, let's say, numbers that weren't straightforward and obvious, I would do 12 plus 10 divided by 2. And then that would give me 22 divided by 2, which would give me 11. So that's my center point. That's my midpoint. Okay? So remember, absolute value is the distance from center. So I'm going to write my absolute value is going to be x minus 11, because it's always opposite of what we see here. And what's my distance? My distance from 11 to 12, or from 10 to 11, is 1, isn't it? That's a distance of 1, and that's a distance of 1. So then that means my distance is 1. So my distance has to be less than 1, doesn't it? So then that means if my distance is less than 1, then I can write less than 1. No earlier than 10, no later than noon. So I could put a less than or equals to sign. So that means I'm going to write this a little bit better so we can see it. X minus 11 with the absolute value less than or equal to 1. So that would be my equation for that particular problem.